Okay, I got another program to show you right here. So what I did, well, let me just show you my code right here. Still have my same functions, and what I'm doing with this code right here is I am building the primordial and the sequence pattern that I've been showing to you guys. And here's where I print the sequence pattern out so you can see it, and then I'm going to pick a random number. I just a 13-digit number so we can test things out. I just picked 1 2 3 4 5 6 7 8 9 0 1 2 3, and I'm going to I'm going to divide that number by 30. Let's see here. Oh, I'm going to divide it by the primordial, and multiply and take the integer of it and then multiply it times the primordial and then add the sequence start. Let me just bring up the program as it ran. Okay, so I'm saying this, if we build a sequence using the primes 2, 3, and 5, so we're saying list some numbers that are not multiples of starting with 7. List some numbers that are not multiples of 2, 3, or 5, these 3 primes, and identify the pattern. So we went over that to begin with before, and that's the pattern: 4 2 4 2 4 6 2 6. Now I'm going to use this pattern right here to help create a list of numbers that are potentially prime. And I just said, alright, let's start somewhere around this 13-digit number right here. This is a random number I picked. So I take the integer of that divided by the primordial 30. So this number, this 1 2 3 4 5 number divided by 30 is this right here, and that's the integer of it. And I multiply it times 30, and that's what I get. And then I add the sequence start, and I end up with this number right here. So starting with this number, what I'm trying to say is if you add the sequence starting at that number, add 4, then you get this right here. So from, see the 27 right here, 127, you end up with 131, right? So 127 plus the 4 equals this 131. So I'm testing this number for primality, and it ends up being not prime as composite, and in fact it is a multiple of 61. And you'll see that it does list some numbers, that 2 numbers that are prime, whereas the rest of them are composite. And you'll notice that all of the factors of these numbers are not going to be multiples of 2, 3, or 5. So anyway, there you go. That right there is an example of using these sequences in order to be able to find a potential prime to investigate. Let me close this right here, and then I'll increase the number of primes that we use in our sequence to 5, or to 4. So let me run the program. Scroll back up to the top. So as you can see, I'm saying let's build a pattern that does not include numbers that are divisible by 2, 3, 5, or 7. And here's the pattern that is built. And I'm saying, okay, let's take this random 13-digit number. Let's divide this number by the primordial, which is when you add up all of these numbers right here, or when you multiply these numbers, these primes. 2 times 3 times 5 times 7 equals 210. That's the primordial. So you take this random number, divide it by the primordial, that's what you get. You multiply and take the integer of it, multiply it times the primordial, that's what you get, and then you add the marker start, or the sequence start, which is 11. So there you go, from 40 to 51 plus 11 is 51, right? So I'm saying starting at that number, add 2, add 4, add 2, add 4, add 6, and so forth. And so these numbers right here, I'm saying, are likely to be prime. That doesn't mean they're probable prime numbers that I'm investigating. It doesn't mean that it's prime. It just means that using this sequence, I can list numbers that are not going to be divisible by 2, 3, 5, or 7. And as you can see, the factors are 109, 103. None of these numbers are going to be divisible by 2, 3, 5, or 7. They're going to, if they're not prime, they're going to be composite, and they're going to be divisible by something higher than 7, such as 11. We can probably find in here one of them that's a multiple of 11. There you go. So that's pretty cool. It helps you create a list of numbers that are potentially prime, more so than the rest of the numbers near and around this 13-digit number. So that's pretty cool. All right.